Yo, yo, yo. So, the plan is to continue with the water implementation today, but yesterday we got a bit sidetracked because there was an edge case concerning the grid, which I want to fix before we continue. And the problem is, okay, now we have a but yeah, the problem was that when we added grass, where we added it didn't really line up where it was added. So the grid, there's a little bit of a weird grid offset that I want to take care of. And yeah, the lines here might be a bit messy, but the thicker white lines are distance lines, if I remember correctly. And the smaller ones are the grid, and we can see here that the smaller ones align with the actual grid. That is good. And the last change we did to the marker, where do we have the marker? We have the marker here. We added an offset to the marker, which works when we don't have any patches, but when we do have patches, we get it wrong. So the marker here should be always located at a pixel. So not in the middle, but at a pixel, because when we add grass, we get a pattern like this. So like the pixels of the underlying texture that represents the data is made in such a way that the middle of the pixel is always located at a vertex. So yeah, when we actually add the data, we get the correct result, but the marker itself is not located in the middle. And we can see here that the marker lines are. So the marker gets truncated by this, and this is what we added for the for it to work on non-subdivided terrains. But this is also what makes it not work on subdivided terrains. So it's like when one explains the problem, it should be pretty straightforward to fix. Unfortunately, I didn't manage that last stream. Hopefully we can get it out of the way real quick now, so we can continue with the water. So now we have a non-subdivided terrain, and if I add grass here and we check 3, we get something like this. Let's see if it aligns with the underlying. Yeah, so this one always aligns. That's good. That's good. But if we take a look at the sphere, let's put it there, and let's take a look at the sphere. Yeah, so this one is located in the middle here. It's very weird. Also, I'm a little bit skeptical about cube. So this is a 1 times 1, right? I think we get the correct distance. This offset grid versus distance, is that something I care about? The bigger problem is this marker. If we can just get that one to work. Like the marker lines are okay. So adding grass seems to be working fine. That's exactly how we wanted to add, right? Good morning, Geralt. Here we get... Oh yeah, didn't we actually... Okay, let's do this. I have a little bit of a recompile issue, I think. So now it should work for this one, but not for the other one. It's a very annoying, but hopefully simple problem to solve. The idea is to never have terrain that is... Yeah, now it works here beautifully. This is exactly how I want it to work. Right in the middle. But then again, if we do 0 here, we have a tiny offset problem. Yeah, both with the grid, both with the marker and, or actually, yeah, not with this one, but with the marker. And it all comes from the fact that let's see here. Yeah, we want the marker to truncate to the middle of pixels, and this actually makes me a little bit... The mesh is done correctly. The marker is not. We want it to truncate to the middle of the pixel. So this is a problem both in marker snapping and grid creation, right? Or is it? No, it's not. Yeah, we can see here that it's both a grid offset, because when we have subdivision, the grass gets drawn at the vertices or at the intersections. That's the points we want to care about, or we want it to be located at. While here we get something like this. Okay, so what it comes down to is, first of all, we have this. When we truncate here, we don't do it the correct way. And terrain delta is the delta of the terrain base. And this one gets calculated like dimensions subdivided divided by resolution subdivided -1. I wonder. So this is one of the culprits. And then I want to check terrain material set material. Here we set a texture, UV scale shader property, and this one we calculate 1 minus 1 divided by patch bounce max. Mesh grid delta shader property name. Yeah, this is the delta and this is patch line. Yeah, this one we don't care about. So it's this one and the previous delta. Patch bounds max is actually equal to resolution subdivided -1. I'm pretty sure patch bounds resolution -1. I think this is correct. The question is, why does the subdivision screw it up? Or actually, let's see. Maybe it's just as simple as yes. Okay, so when we divide this one into patches, we actually get, so let's say that we divided it into 4 patches. We actually get 4 patches where all meet at this point. So is that the actual offset? And how would one go about solving that? It basically comes down to wanting to have, let's see here, can I check? We don't have any mesh information. But we basically, if we don't subdivide, we want 1 more pixel. Is that it? I want to try and generate, because if I'm just going to show real quick. So if we subdivide this one, then we get something like this. And this is Origo. So do we get 1 grid more if we subdivide? Let's do environment, dimension. I don't care about dimension. Let's go 8. So if we subdivide now, we should get, we get, let's see here, we have subdivision 1, resolution is 8, we have subdivision 1, so 2 times 2. And we get a resolution of 3 per each. We get 4 vertices, so that's good. So we get 2 times 2 patches, so 4 patches, and each patch has 4 times 4 vertices. If we don't subdivide, yeah, then we only get 1 patch, but we have 7 times 7 in resolution. Beautiful. Okay. So what it basically comes down to, I guess it's this one. Or no. 1, 2, 3, 4, 5, 6, 7, 8. We get the correct amount of vertices. It's just that we actually get this one. So what if we do a subdivision constant of 2? What is that? 2 to the power of 4. I don't even know. Yeah, we get 4 patches and each of them has 2. Yeah, that's good. So it works for everything but subdivision 0, and it's not that it doesn't work for subdivision 0, it's just that the way we build it like it's the correct amount of vertices, correct amount of patches. Correct amount of pixels, but they are located. So what, like we center it. Yeah, and it's the centering that is the problem, I would say. Fuck, is this a problem? I even, like, the quickest fix here would just be to offset it by 1 pixel. But still. Oh, yeah, by 1 terrain data. 1/2 terrain data pixel. But it's also a problem of so basically when we subdivide it, we split here, and then reorder the remaining. Fuck it. So like splitting it introduces additional vertices, but these additional vertices overlap. Yeah, I don't really know a way. around this unless you add in conditional offset. So we could do, and yeah, we also need it for, let's see. Yeah, okay. Let's go down to 8 again. Yeah, so for 8 we get 7 quads, but 8 vertices. If we add a subdivision, we get 8 vertices, but we only get 6 quads in total. So it's the amount of quads. Could we fix it by doing... Is it always 1? What's up, Namida? Thank you, appreciate it. So 1, 2, 3, 4, 5, 6, 7, 8. Still 8 vertices, that's good. But we get 4 quads. Yeah, for each subdivision we still have the same number of vertices, but we lose. So 7 quads down to 6 quads, down to 4 quads. Let's see, there's a mathematical pattern to this, and I wonder if it's... So per patch, let's see here, 7, 6, 4. Is it number of patch intersections? Yeah, it is. So we lose one quad per patch intersection, right? Yeah. Yeah, because each patch intersection leads to overlapping vertices, which we want it to do. So, knowing this, could we do a prettier non-subdivision case? That is the question. We don't want to add vertices. We don't want to change the size. Probably the best, like, yeah, it would probably be to just do this. Let's see here, environment 0.256, and then we do terrain base. And we just add an offset to delta public float offset. Yo, good morning, Fabic. Private set. We just add this one. It's 0 by default, but if we have a subdivision, so yeah, just a very simple offset. If subdivision is equal to 1, offset is equal to is it 0.5 times delta? I think so. And then we just need to use this one in, we can start by using it in Yeah, I think we can start by using it in Action Terraform. Do we have offset here? No, good. So we use terrain delta, private float terrain offset. Plus terrain offset times vector 3.1. Although I'm worried about y here, I don't think we need to truncate it based on y, so probably gonna remove that as well. So nothing should have changed except for this sphere here being located in the middle of the grid instead of yes. And I just want to see if this works with 1 as well. And then we need to communicate this data to both the grid shader and the terrain shader. And then we should be done. It's a very special case, I would say. So fuck, did I screw it up? Grid line. Yeah, I did. No. Nah, it's perfect. Good. So this one is not with us here. So let's take a look at terrain, something, terrain procedural grass shader, terrain grid color with delta. Mesh grid offset, and how do we want to use this one? We want to use it down. I'm wondering if it's probably okay. Calculate grid value. What can we do here? Input position world space. We can actually offset this one. I wonder if this is okay, writing it like this. But then again, let's see here, mesh grid. Yeah, it's only on this one we want to add it. Let's see if it works. So 0.25 would be the correct one, and that is equal to what did we have? 0.25. Yeah, 128 divided by 256 and then times 0.5. So it is the offset. What bothers me here though is that we calculate the offset here. But then we need to send it in. We could probably, like, we could set a lot. Yeah, earlier we set a lot of things like here, but we could probably set it in terrain base. Like, these properties are going to be the same for like this, yeah, we have all of these values outside initially. Do we really need them in here? Can I imagine a case where we want to set these? Now, like, it's the terrain base that controls all of these properties. Could there exist a case where... No, I don't think so. I think we're gonna bring these out. The only property we want to set from patch is basically this one. So what do we have? Texture UV scale, texture UV offset, grid, and patch line. Yo, what's up, GK? Yeah, we just want to move these out, or we want to move them up a level, pretty much. But it's not all of these, it's these four. Terrain base. And the question is, I don't even know where we want to have these in the end. Anyway, private const string terrain mesh grid offset shader property name. Mesh grid offset, if I remember correctly. So we keep them here. We take these and we put, do we want to do it when we generate? Yeah, we want to do it when we generate. We want to do it here. And the material in question is terrain material. So we can just replace this, 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 and this. And now it's a question of, so patch bounce max in patch is equal to resolution minus 1. If I remember correctly, where do we have instead? Patch bounce, there we have resolution minus 1. So it's basically resolution subdivided minus 1. And then we don't want dimension here nor here, we want dimension subdivided. And finally, we also want here. Terrain offset. And we just add offset there. I think that's what we want to do. So we have a terrain material here. We set all of these, and then we send down to each patch set material to this one. This call is basically going to create a new instance of it since we do this. But hopefully, if my understanding is correct, this should still hold. Good morning, Desai. Hopefully this can finally fix this weird little edge case. So the fact is, our terrain is mostly vertex focused and not quad focused, which means that, like, independent of how many times we subdivide, we always have the same amount of vertices when it comes to length. But the more times we subdivide, the more overlapping vertices we get. And when we subdivide 0 times, we don't get any overlapping vertices. Instead, we get a little bit of an offset. And that was the entire cause of the problem. Will it work between patches now? We'll see. We'll see. Hopefully. So what do we have here? This one works. This one works. Although yeah, this one isn't fixed just yet. But if we do this, and then we do we have a little bit of a problem here. I don't know why. Ah, yeah, we haven't edited the other one as well. Let's see here. Shift 3. Yeah, now it works. Each pixel is located in the intersection of a grid. The grid we move around here does not work just yet. We haven't fixed that one just yet. I want to fix that one first, and then we'll see if it works with subdivision as well. But if we take a look at the sphere itself, it's actually located in the middle here, so that's perfect. So, yes. And as for that question, Fabric, yeah, I hope so. We're gonna try it. We're not really altering how anything looks underneath. We're just altering the representation of the data that is underneath. And we only do it if subdivision is equal to 1. Or we could actually do it like if subdivision constant is equal to 0. So the calculation of delta, you have it right here. If that's the one you're asking about. Yeah, it should. I hope it should be fine, but we'll see. And now we also want to fix Terraform visual point marker. What is terrain marker? I think it is. Yes, terrain marker. So we need to introduce, just like we introduce grid delta, we need to introduce grid offset. No problem at all. Like iterating things helps my understanding of things as well. Sometimes also highlights errors. Grid offset, and then hey, we should be using to do use util helper functions instead. World position, because we actually have, and here we fuck, do I want to do this now? Maybe I do. Nah, I want to, let's just leave it as a to-do. But what we should do then is plus grid offset here, right? Pretty sure. What's up, Ayland? I think we should do it like this. That's right. And of course, we need to set it as well. Here we have shader, property name. Here we don't. And then we want to add private. It's a little bit dirty, but I will leave it for an iteration. Yeah, now it works, but this one still... It doesn't... something is off at the with the feel of it. Is it because of the height? We probably want to bring it down anyway. Yeah, because like if I highlight this one, I want it to be the if we go all the way here, it just switches when we get to here, so the truncation is a tiny bit wrong. So when we have fixed the visuals, do we not need... So we offset the grid, we offset the... Or did I not offset it by half? But I don't know. No, it's entirely off. Could it be the height? That is my question. So here we basically just want to do new terraform point.y. Yeah, that is interesting. Yes, of course. So if we keep this one as that, yeah, what we want to do is new terraform point. Times this one times this one. Y should be as is, so wherever the intersection from the ray and the terrain happens, that's where we want our marker on the Y. We only care about the grid position in X and Z, and that's what we truncate here. Divide, round, multiply by terrain delta, and then we add a terrain offset. Oh, sorry. I must have been... Thank you, Ayland, for that. Yeah, I must have been muted. I don't know for how long. But okay, the fact is that the offset we add is in the wrong place. Because what we're doing here right now is we take this point here and then we truncate. So wherever we have the marker, we truncate to the middle of the pixel. And then we add, so we get to this point at the end, but we truncate at the wrong place. That's what we're doing. Or we're truncating based on... Yeah, we're truncating to the wrong place, I think. I thought you were brainstorming. Yeah, actually I was. But when I stream, I try to put my brainstorming into words. I don't know if that goes against the definition of brainstorming, but yeah. Also, I've been here since the first 20 minutes and haven't heard a single word. I sure as hell hope I haven't been muted that long. Don't think so. I've said a lot of mornings and stuff like that. But yes, I was concentrating, I was brainstorming, but I was also talking at the same time. Unfortunately, muted. But that's how it goes sometimes. Good morning, by the way, Cooler SK. I appreciate it, Fabik. I appreciate the kind words as well. Yeah, Cooler SK. I'm actually back to tea only now. Very nice. Haven't actually found like the haven't found the teas on my to try list yet, but I found this very amazing summery tea. But I go through a bag like in a week, so probably gonna go to the shop soon again. Robin, what do you think about the Unity corporate drama? I hate it. I'm very... How should I put this? I hate... Like, of course everybody wants to make money, but... I hate when it becomes too apparent that the top level is only in it to make money, and a lot of it. So like, yeah, I'm worried about the corporate drama, but I try not to think about it too much. Worst case scenario, I will have to switch engine. Name of the tea, unfortunately we were in like last Thursday was Sweden's National Day, or whatever the name in English is. So we were actually at like a fair where people sell stuff they make themselves. So I bought a bag of green tea from them. Maybe I should say the name. Maybe, yeah, we'll go grab the bag later on. But like, it's very, yeah, it's probably only available in the south of Sweden, I would guess. Okay, so as to the brainstorming session, Craft Good Fare, yeah, it probably was. Also picked up a jar of honey. We picked up so many things, but pleasantly surprised by the tea. So what I think is that this terrain offset is done I tried adding it here and then divided by terrain delta. I think we want to do soon. I'm gonna lose it, but we're not there just yet. Does this make sense? We get the point, we divide it by terrain delta, then we add offset, then we round it. I'm not sure. Elon, I'm creating a system model simulation based on the Keplerian elements. Yeah, I have to agree, that sounds like a lot of math, but it also sounds interesting. What exactly are the Keplerian elements? Yeah, and this is not correct either. Fuck, is it? No, it's not. But. Yeah, now we're just gonna brute force this. But then do we need to add the same here? Maybe. Oh, everything went so well. Just up to this issue. And I have to say also, like the way... I think the way we... Okay, that's the worst one yet. Oh yeah, of course, that's wrong. Like the fact that we have made our vertices be located in the middle of pixels has helped a lot at the back end of things. But when it comes to like the visuality of it has actually complicated things. This doesn't make sense. The terrain delta is the same. The offset is not. Just you wait for the info that you get from the beta. Yeah, the testers, yep. It's gonna be a long list. But everything that helps towards a good final product is welcome. What the fuck? What? It is more simple of Keplerian elements. All the orbit are perfect circles. I still don't know exactly what it is. rings a bell. Hell yeah, it does. But what exactly is... Okay. Programming is easy, writing bug/exemption-free code is hard, indeed. Cooler SK, we are 100% winning at grass. It's grid lines that are beating our asses. Okay, so let's take a look at this one. Or this line. We get the collision point, and then we truncate that collision point. We take a collision point, divide by terrain delta. The terrain delta is non-offsetted. Then we multiply with terrain delta. We want to offset this one, right? But like given the error we get, given the error we get, this should probably fix it, but like it's just that we have a tiny bit of an offset between the visual grid we get and the actual point I'm marking. So it's easier to see here. So even if my mouse pointer is here, the middle point on the grid should be this one. But we're getting a little bit of an... Yeah, we are always offsetting in the... Is it the positive direction? Yeah, it is. Actually, so moving the mouse pointer within a square like this should, like now, here we should highlight this one. Here we should highlight this one. We go one exact delta. And that's like the whole problem is that we're... Oh yeah, that's a complicated formula, isn't it? The whole problem is the truncation. We're truncating to a non-offsetted grid. We want to truncate it to an offsetted grid. But we have to be... So if we don't have any offset, then we mark the... What I hate... Oops, we don't want to do... is that our... the circle itself, the middle of the marker actually gets set correctly. It's just a difference between the mouse pointer and where the marker end up. That is a little bit disturbing. So what it all comes down to is that the difference between this one and this one is too big in one direction. So how do we actually take the offset into account in the correct way? And that is true, Aland. It seems pretty straightforward to just convert into code. Yeah, the bottom line is that we need to introduce the terrain offset here before we truncate it, right? Like, the more I think about it, this but no. We don't want to add an offset to the pointer itself, but we want to add it before we round. Right? So we get the yeah, we get the index, but we get it as a float. And then we add the terrain offset. Then we round it. No, okay. So, okay, don't we want to offset it by... So if we offset it here, we want to offset it by... Right, so this is a floating point number. Yeah, and then we want to offset it by 0.25 divided by 0.5. But if we offset it by like this, we can add it here, which we have already tried. Does this make any sense? doesn't. So mathematically this is correct. It's just the difference between the mouse pointer position and the endpoint we get that is annoying. Yeah, so we need to add does the terrain offset need to be sign based? Like sometimes we want to add the offset in one direction and sometimes we want to add it in the other direction. Extremely frustrating. So right now we truncate it to the middle of a quad, or yeah, middle of the square. So here, here, or here. And then we always add the offset after the truncation. But we want to add it before, right? Or we add the offset, yeah, we add the offset after the truncation, which results in this mismatch between mouse pointer and what we want to truncate it to here. But if we always add an offset, yeah, like sometimes the offset should get us from this point to this one, but here we should get from this point to this one. So we do want to add it in the direction of like if we add the offset to the mouse pointer, we get to this point, but then when we truncate it, we'll get to this point. Is that actually what we want to do? But if we add it, is it a question of adding the offset here, calculating the truncated value, and then removing the offset? Because given this, the truncated value is always going to be in the middle. So if we do this, for instance, then we get, so if the mouse pointer is here, we add the offset, which is half, so we get to about here. So then when we truncate, we get to this point, and then if we subtract the offset, we get here, which I think is correct. And if we're here, we add half the offset, we get to around here, then we truncate it, we get to here, and then we, it makes a little bit of sense. A tiny bit. It makes a lot of sense. Yeah, it does. Yeah, it does. Okay. Nice. No, honestly, this would only be a problem. This would only be a problem, first of all, if we have a terrain that is not subdivided. We will never in-game have a terrain that is not subdivided. Second of all, if the player could see the mouse pointer at the same time as he or she sees the terrain marker, and that will never happen. So right from the beginning it has pretty much been a non-issue, but I wanted in the I wanted it to work the correct way. I think it will help quite a lot when we do the water, which we are now finally ready to start looking into again. Oh, do we actually have a noise? That is beautiful. Okay, but great. So, I think we can jump over to the water from the get-go, and if we take a look at, that's beautiful. We had one problem with, like, if I add water here, we don't get a instant change, but if we do this and yeah, if we do this and then we add grass, then we get the water. 7 minutes to implement the water. Yeah, let's go. So if we add water here, we don't get an instant change, but if we add grass here, we get it. So that's just a mismatch in terrain patch. Fluid, I thought. Terrain data container. Set fluid amount. We set it on the CPU, we don't do it on the GPU. Is it just a question of apply? Render texture. The question is data as render texture. We could probably, for now, this one is old as well, but we could probably do with just this for now, I think. And that would fix the issue at hand. Having the render texture being synced to the texture to the object is relevant when we work with grass and height, but not with water currently, I don't think. Okay, so this is grass, water. Okay, beautiful. I think this is not that bad of a spot to quit on. So tomorrow we can actually get to implementing the fill algorithm. Oh, beautiful. Yes, we got a little bit sidetracked, but I really wanted to get this marker working before we went on to much more difficult things. And okay, I might regret this, but I think the approach we're currently going with when it comes to the water isn't that complicated. I think it's quite clean and hopefully not too complicated. The complicated part is going to be to implement it in a compute shader, because I don't think it depends on if compute shaders has some extra functionality as opposed to some extra functionality I need as opposed to shaders. Like, my biggest concern is that like the whole water system is gonna be a hell of a lot of convolutions, basically, but we need to make them in a specific order. That is what worries me, the order. It had to be done indeed, and don't clip that. Because basically what we're gonna do is when we add a water pixel here, what the fuck, do I see an offset? Fuck. Damn it. Yeah, we do. I think we'll see if I have time to fix that small offset off stream. But because tomorrow I want to do water. And what we're going to do is we're going to add water to a pixel like this. And then we're going to go to each of its neighbors and check, do a convolution basically. But the convolution is a max convolution, so given this pixels, fill this pixel with the maximum amount of the neighbors has, and then we're going to extrude outwards and outwards and outwards. Should be pretty straightforward on the CPU. On the GPU I have no idea. But yeah, that is hopefully what we're going to do tomorrow, because now I gotta run. But thank you all for watching, and have a great rest of the day. Peace.